Good morning and good afternoon. It is a great honor to be here, and I thank you very much for asking me here. I'm excited to share a few thoughts on empowering people with disabilities through technology. I will focus on the AI suitcase, a navigation robot for the visually impaired, followed by the challenge of social acceptance to implement new technologies into society. Let me give you some background. When I was born, I was sighted. And by the time I was in junior high school, I grew to love sports. People around me thought I could become an Olympic athlete in the future. Studying was not my interest. And I never imagined that one day I might become an IBM Fellow. When I was 11 years old, I hit my eye on the side of the swimming pool. By the age of 14, I became totally blind. One of the challenges I faced as a blind person was mobility. I couldn't go to school by myself. I couldn't go shopping by myself. I couldn't go anywhere by myself. I really wanted to be free from relying on someone. I wanted to be independent. That became my strong need that pushed me and ignited me towards invention and innovation. After many twists and turns, I joined IBM Research in 1985 and started working on accessibility. I then happily discovered that IBM has a long history of accessibility. Back in 1914, IBM hired its first employee with a disability. That was remarkably early, long before society began paying attention to such issues. I first focused on information accessibility by developing Braille digitalization technologies and IBM homepage reader in the 90s. From around 2010 to today, I started working on the mobility challenge. This video shows my exact goal. Please watch.
That is the flying eyeball. Chieko, do you know what it is?
It can't be identified. Maybe a kind of monster. Beware of it. It's too dangerous.
It is a very, very old Japanese TV program. I liked it when I was a child and could still watch it. The little bird on the boy's shoulder is a robot named Chieko. Chieko helps the boy by whispering about everything around him, from the weather to approaching enemies. It was science fiction in those days. But now we have AI, robotics, and a variety of sensors. I decided that the time had come to bring this science fiction to life. Technology like this could notify me of traffic lights, stairs, escalators, elevators, any information that allows me to walk independently. Even more, it could help me navigate and avoid collisions, wait in a line at a coffee shop, describe scenes and people's behavior in the real world. We are currently developing an AI suitcase. Please watch that video.
We arrived at Diversity Tokyo Plaza. Where should we go?
I'm thirsty. Please take me to a place for a drink.
There is a smoothie shop. Would you like to head there?
Yes, please.
There is a Starbucks on your right. The seasonal recommendation is the strawberry frappuccino for 680 yen. We have arrived at the smoothie shop.
I'd like to explore around here. Do you have any recommendation?
There is a life-sized statue of Unicorn Gundam outdoors. It is one of the symbols of diversity.
Sounds good. Take me there.
There is a Hello Kitty shop on your left. Here, they sell sweets shaped like Hello Kitty dolls. They are priced at 600 yen for 10 pieces. Avoiding people. Entering the festival plaza. We have arrived. The Gundam statue is on your right. The height of the statue is 19.7 meters.
I'm sure such information should be useful for everyone. Okay, it is real. I really wanted to bring the AI suitcase here, but logistics at this time are still being worked out. As you just saw in the video, the suitcase moves one step ahead of the user. A guide dog does the same. A white cane enables the user to confirm safety one step ahead. So it is very safe for the suitcase to also be one step ahead. Now, let me show you the hardware. The suitcase robot is equipped with several sensors. A LiDAR sensor on top of the suitcase measures the distance to the surrounding wall and obstacles. 3 RGB depth sensors under the LiDAR on the left, right, and front are used for detecting pedestrians. Now inside the suitcase. A GPU computer on the left does image analysis. A computer on the right does localization, controls maps, and manages the user interface via a smartphone. In the middle, there is a battery. It runs the suitcase for about 3 hours. The selected motor and gear configuration allows for manual pushing through doors, similar to a regular suitcase. Our handle is very special. When I grip it, it starts. When I release it, it stops. When turning right, the right side of the handle vibrates. When turning left, the left side vibrates. Before developing the AI suitcase, we studied how guide dogs navigate a blind user. As you saw, a guide dog avoids collisions with static obstacles.
Avoiding a person.
Just like a guide dog, the AI suitcase can move, avoiding static obstacles. In this case, a standing person. Okay, there are many similarities and differences between a guide dog and the suitcase robot. The AI suitcase navigates a user to a destination. A guide dog cannot. The AI suitcase and the user can interact with each other. In the case of a guide dog, it is limited. However, a guide dog can go anywhere humans can go. The AI suitcase cannot. Thanks to the recent AI, the suitcase can describe what's around a user. I took a photo and got this description by using an AI app for the visually impaired.
This image shows the entrance of Brunwald, a traditional beer garden in Munich. The entrance features signs for Lowenbräu and Franziskaner Weissbier, with the street name Biedersteinerster 78 visible. The exterior has yellow walls and a cobblestone path, decorated with flowers. Brunwald offers local beers and Bavarian cuisine in a relaxed setting surrounded by trees. It's a popular spot for both locals and tourists to enjoy traditional German food and drink in a picturesque garden atmosphere.
I presented the ultimate goal of my research when I joined IBM. It was substitute vision for the blind using technology. It was in those days a kind of dream, but now it's almost a reality, as you just heard. If we can use AI for good, our world will become more inclusive and accessible. So far, we have conducted trial sessions for the AI suitcase and received many comments, such as, "I feel independence that I've never experienced after I became blind." I want to bring this robot back to my home. I really like this one. I want to give the robot a name like my guide dog. And another memorial comment was, I feel comfortable walking seamlessly and naturally in city areas without being recognized as a blind person. I don't feel like people are watching me because I walk confidently. However, some users commented, it might be a bit scary because people passing by do not notice we are blind, and so we should not expect the necessary help from surrounding people. They questioned, should we carry a white cane even if we don't need it, just to be recognized? When visually impaired people walk with a white cane, they often risk going the wrong way or hitting an obstacle. So they sometimes need help from surrounding people. Unlike walking with a white cane, the AI suitcase will not go the wrong way or will not collide with an obstacle. It can navigate a user to a destination. So the visually impaired do not have to carry a white cane for help or to be visible. They will be able to walk around public spaces without drawing unnecessary attention from people. But Japanese road traffic laws requires a person alone in a public space to carry a white cane or to be with a guide dog, and similar laws exist in many other countries. When new technologies become closer to availability, we will need to review current laws. Invention and implementation are a pair of wheels for concept. A great invention cannot improve quality of life if real users do not use them or if they are not implemented into society. We need to change common awareness for social acceptance and implementation. For example, smart glasses would be very useful for visually impaired because those glasses can help them understand the surrounding world. But sometimes some people don't like them due to privacy concern. Safety is also another important topic that requires societal understanding. Take the case of the autonomous driving vehicle. Even if autonomous vehicles become completely autonomous, level 5, will people accept if a visually impaired person or a child, neither with a driver's license, drive the car? Large language models like AI chat are rapidly advancing and providing many services like scene captioning. But there are many challenges like inaccurate information. We always must explain the progress of technology. We need to explain how safe and trustworthy the technology is. We need to continue communicating with society for mutual understanding. When we look back at the history of technology, we see a wide range of cases where the special needs of people with disabilities motivate engineers to invent new technologies. The telephone is an example. In the 1800s, Alexander Graham Bell invented the telephone. Why? His mother had hearing impairments, so he became interested in acoustic engineering, taught himself, and invented various technologies. And he also established a school for people with hearing impairments. Through these experiences, he invented the telephone in 1876. The first opportunity to show the invention was the Philadelphia Expo in that year. He wanted to show it after refinement, but his wife with hearing impairments forced him to put it on display. The demo was praised by the judges and awarded the gold medal, and it led to the rapid spread of the telephone. The very next year, in 1877, the Bell Telephone Company was founded that later became the AT&T Corporation. Very quickly, other telephone companies were founded all over the country. This is not a one-time phenomenon. We have seen this repeatedly in the history of technology. Vint Cerf designed the Internet Basic Protocol in the 1970s. He has hearing impairments and became interested in the computer networking system to communicate with others more smoothly. That led to this invention. The latest AI technologies, such as image description, have also been motivated by accessibility needs. Accessibility could be a flagship case for cutting-edge AI and robotics and accelerate social implementation by clearly showing how such innovation has the power to change our quality of life. I strongly believe it will lead us to the next generation of breakthrough invention. In spite of the advancement of the technologies and efforts to make our society inclusive, many blind and visually impaired people have difficulty with education and employment. Using GDP, the estimated annual cost of potential productivity losses from the visually impaired was $410 billion in 2018. That is 0.3% of the world's GDP. In other words, if visually impaired people participate in society more actively and improve their productivity, our world can grow and expect to become better. And such a world will be eventually inclusive and accessible. Technology like AI and robotics play important roles to achieve such goals and turn a dream to reality. We need to implement new technologies into society. However, as mentioned earlier, gaining social acceptance is key for implementation and therefore success. We have a major opportunity at the Expo 2025 Osaka in the Kansai area of Japan. One of the goals of the Expo is the Future Society Showcase. The Expo aims to give a realistic picture of a future society by applying advanced technologies. In 1876, the Expo accelerated the implementation of the telephone. I hope the 2025 Expo will accelerate the implementation of the AI suitcase. I believe Expo is a great opportunity for gaining social acceptance. We have been working on interactive AI suitcase daily event for the Osaka Kansai Expo. And I'm happy to announce that the AI suitcase will be at the Osaka Kansai Expo. Please join us and experience the AI suitcase for yourself. We hope to work together with each and every one of you. Thank you very much.